Hello students, let us continue with the chemical properties of alcohols. The last set of reactions are oxidation reactions. Now this oxidation reaction of alcohols involves cleavage of both OH and CH bond. Shift in the position of pair of electrons between O and H, as I have indicated in the arrow here, will lead to the formation of a C double bond O, that is carbonyl bond. Such reactions are also known as dehydrogenation reactions because there is loss of H2 from an alcohol molecule, resulting in the formation of the carbonyl group in the product molecule. Now if you look to these oxidation reactions here, the first set of oxidation reaction, that is an alcohol on oxidation with acidified potassium permanganate, that is KMNO4 in H2SO4, is oxidized to an aldehyde. There is elimination of a water molecule from the corresponding alcohol molecule, yielding an aldehyde. Further oxidation of this aldehyde in the presence of acidified potassium permanganate will give the end product as a carboxylic acid. That is the end product. Now if you take one particular example, CH3CH2OH, that is ethanol, on oxidation with acidified potassium permanganate will form the aldehyde ethanol CH3CHO, whose common name is acetaldehyde. Further oxidation of ethanol in the presence of acidified potassium permanganate will give the product as CH3COOH, that is acetic acid or ethanoic acid, as the end product. Suppose if we want to stop the oxidation at the aldehyde, or if we want to isolate the aldehyde and we don't want the end product as a carboxylic acid, then the same oxidation of a primary alcohol RCH2OH is carried out in the presence of chromic anhydride. CrO3 is the chemical composition of chromic anhydride. This will yield to the formation of an aldehyde and byproduct water molecule. Further oxidation of the aldehyde does not take place. Now another better reagent for the oxidation of primary alcohols to aldehydes to get good yield of the product, that is aldehyde, is PCC. Now PCC long form is pyridinium chlorochromate. It is a complex of chromium trioxide with pyridine and hydrochloric acid. If you just remember the name, it is more than sufficient. You need not remember the composition. That is for your information. PCC is pyridinium chlorochromate. So if you take one particular example, the example taken here is but2-ene-1-ol, bifunctional compound having OH and a double bond on oxidation using pyridinium chlorochromate. So a double bond is introduced with the elimination of a water molecule. The product formed is but2-ene-1-ol, that is CH2OH group is converted into CHO, aldehydic functional group. So that is the product formed. If you take secondary alcohols, now this is the general representation of a secondary alcohol, RCHOHR'. So secondary alcohols are oxidized to ketones in the presence of chromic anhydride, that is CrO3. So elimination of H plus and H minus as H2, OH pair of electrons are shifted to the carbonyl group and you will get the product as ketone RC double bond O R' plus H2O. So this is the secondary alcohol forming the ketone. Remember, tertiary alcohols are resistant to oxidation. This is a very important point. So tertiary alcohols do not undergo oxidation reactions. The reason is that cleavage of both OH and CH bonds is difficult. However, if you use stronger reaction conditions in the presence of acidified potassium permanganate and elevated higher temperatures, you will get a mixture of carboxylic acids which have lesser number of the carbon atoms than the corresponding alcohol. So remember, it is very difficult to oxidize the tertiary alcohols. Now, as you all know, the physical state of alcohols is liquids. Yes. Now, these alcohols on heating above their boiling point are converted to vapors, right? So, if you take vapors of a primary alcohol or even a secondary alcohol and pass these vapors in the presence of copper catalyst at an elevated temperature of 573 Kelvin, the product formed is an aldehyde with the liberation of hydrogen. This is called as dehydrogenation. H2 is eliminated. So if you take one particular example for a primary alcohol, ethanol vapors CH3 CH2OH on passing through copper catalyst at 573 Kelvin temperature, the aldehyde formed will be ethanol with the liberation of H2, that is hydrogen. Now if you take a secondary alcohol, vapors, pass them through copper catalyst at 573 Kelvin, you will get a ketone, that is RC double bond O R dash with the elimination of H2, dehydrogenation. Now the example taken here is that of propane to all vapors. When passed over copper catalyst at 573 Kelvin, you will get the product as propane to one plus H2. Upward arrow indicates that hydrogen gas is being liberated. But if you take a tertiary alcohol, the general representation is here RC, R dash, R double dash OH. Vapors are passed over copper catalyst at 573 Kelvin temperature. You will get an alkene RC, R dash, double bond CH2 plus H2O. This is not a dehydrogenation, but here there is elimination of water molecule. This will be clear when you look to the particular example here, that of tertiary butyl alcohol, which is also called as tertiary butyl alcohol, which is called as 2-methyl propane to all. So vapors passed through copper catalyst at 573 Kelvin, H and OH, H from a methyl group, adjacent methyl group is eliminated so that it forms a methylene group, CH2 group, and you will get the product as 2-methyl propene with the elimination of a water molecule. H2O is eliminated. So this is with the tertiary butyl alcohol or 2-methyl propane to all forming 2-methyl propene. So these are the chemical properties of alcohols. Now to wind up, you should know about some commercially important alcohols. So there are two important commercial alcohols. The first one is the first member of the alcohol family itself, which is methanol. CH3OH is methanol. Now this methanol is also called as wood spirit. I will tell you the reason why it is called as wood spirit, because earlier wood was subjected to destructive distillation when you would obtain volatile vapors, and these volatile vapors on passing through aqueous solution would lead to the formation of an acid called as pyroligneous acid. So therefore it is also called as wood spirit. Whereas today commercially most of the methanol is produced by the hydrogenation, catalytic hydrogenation of carbon monoxide. CO is carbon monoxide at a high pressure of about 200 to 300 atmospheres and a high temperature of 573 to 673 Kelvin in the presence of a catalyst mixture of oxides of zinc and chromium, that is ZnOCr2O3. Zinc oxide, chromium trioxide mixture is taken as a catalyst, so that you will end up with the product as methanol, CH3OH. So this is the commercial preparation of methanol. Coming to the characteristic properties of methanol, it is a colorless, inflammable liquid. Inflammable means it catches fire easily. Even its vapors catch fire. Hence it is called as inflammable liquid with boiling point 337 Kelvin. Remember that ingestion of small amounts of methanol will affect eyes, causing blindness. It is highly poisonous in nature, and if ingested, if taken in large quantities, methanol leads to death. Coming to the uses of methanol, methanol is used as a solvent for paints and varnishes. Another important characteristic use of methanol is in the manufacture of the first member of the aldehyde family, formaldehyde. Methanol is the IUPAC name of formaldehyde, HCHO. So these are the important uses of methanol. Now coming to another commercially important alcohol, it is also ethanol or ethyl alcohol, CH3CH2OH. Now coming to the commercial preparation of ethanol, it is carried out either by the fermentation of sugars present in molasses and grapes. So I hope you know what is molasses. Molasses is the mother liquor left after crystallization of sugar from sugarcane juice, which is a dark syrupy liquid which has 50 to 55% of uncrystallizable sugars, that is sucrose, glucose and fructose. Now coming to the making of alcohol ethanol from grapes, it is the end product is called as wine. So sugar and yeast both are present in grapes. When grapes are crushed, both enzyme and sugar interact, and a very important process called as fermentation begins. Now I hope you all know what is fermentation. It is breaking up of complex molecules, sugar molecules into alcohol molecules under anaerobic conditions, that is in the absence of air, and there is liberation of carbon dioxide. Now there are two important enzymes present in yeast. The first very important enzyme is called as invertase. Invertase is the enzyme present in yeast which breaks down the disaccharide sucrose, C12H22O11. It is hydrolyzed to a molecule of glucose, C6H12O6, and a molecule of fructose, C6H12O6. In turn, there is another enzyme called zymase, which breaks down both glucose and fructose, which are functional isomers having the same molecular formula, C6H12O6, to ethanol, and there is evolution of carbon dioxide. So this is the preparation of ethanol, C2H5OH. Coming to the properties of ethanol, it is a colorless, inflammable liquid, and it has a characteristic odor. Boiling point is 351 Kelvin. Now, a very important characteristic property is it is miscible with water due to formation of intermolecular hydrogen bonding, and it is also soluble in organic solvents. Now coming to the uses of ethanol, a very important use of ethanol is in the manufacture of a variety of alcoholic drinks. It is used as a beverage. It is also used as a solvent in paint industry, and a number of carbon compounds can be obtained from ethanol. Another property you should know, that is denaturation of alcohol. Denature is loss in the properties of alcohol. Now ethanol, the commercial alcohol ethanol, is made unfit for drinking by mixing copper sulfate, CuSO4, and pyridine C5H5N, which is a heterocyclic compound, a foul smelling liquid. So the characteristic properties of alcohol are lost. This is known as denaturation of alcohol. If you know these uses, it is more than sufficient. So end of the topic, alcohols. I hope most of the things are clear, students. Write the notes, keep it up to date, revise properly, so that we will move to the next chapter, that is phenols. Thank you.